Hello, my name is Dolan. Welcome to my channel. This is a place where I test out project ideas and then share them to YouTube, hopefully to inspire people so that you might have some reference when you work on a similar project. Today I'm talking about how I use AWS Glue and Lambda to create a data pipeline for a fictional logistics data project for a copper mine in Bagdad, Arizona. The copper mine is real, but the data is fake, and I generated the data about me. Okay. Okay. This is me. I am a geospatial analyst, imagery analyst, and data scientist. I did all three of those jobs for the United States Department of Defense, but it's now the Department of War. I'm currently a geospatial engineer with my current job outside the government. I spend a lot of time working with the cloud, so I like to consider myself a data cloud practitioner, and I'm a Korean corn dog aficionado, and that's a quick introduction to me. The purpose of this project is to practice my AWS cloud and Python skills, and again, share them out to you, hopefully to inspire you to do something similar with your project. Sorry about that. So why did I choose this project to do? Well, I wanted to work on something that I was familiar with. And after spending 25 years with the U.S. Department of Defense, I didn't want to share a project idea that might get me in trouble on YouTube. Mining is something that I am familiar with. I am from Bagdad, Arizona, where the copper mine is. My dad worked at this mine. I worked at this mine myself during summertime when I was in college, and my uncle has worked in this mine. So it's something that I'm familiar with. And plus, mining is a complex industry that I feel is very data rich, a very data rich environment. I mean, at a mine, you have instrumentation to control processes. You have devices collecting temperature, pressure, and things like that. You have power and utilities that require the lights to be on 24/7. And then you have plant logistics. So you have bringing commodities in and then bringing commodities out. And that's one thing that I'll focus on with this project is the logistics needed to support plant operations. And also, in my opinion, big data analysis and machine learning is important to identify potential shortcomings and mining processes that could lead to an environmental catastrophe. And I give you an example of that. When I was 8 years old, my father worked at a mine in Papua New Guinea, a mine in Octedi. And he came home one day and he said, so the mine accidentally released cyanide into the river and killed a bunch of crocodiles. This really was an understatement. It was really quite a bit of an environmental disaster at Octedi in Papua New Guinea. The mine uh, had a lot of chemicals dumped into the river, causing severe impact on the regional environment, impacting the local population. And I think the company had to end up paying millions of dollars in fines to the local people. It was so bad that even the World Bank called for the Octedi mine in Papua New Guinea to close following the leak. I mean, it was much worse than what my father described when he came home one day. And so mining is something that I think should be done responsibly, using data analysis to identify problems before they happen. So with the scope of this project, I'm going to focus mostly on AWS Glue and Lambda scripts to perform some data engineering, although I could go back and add things like AWS Event Bridge and AWS SNS and maybe even a web app to this project to kind of beef it up. But the fact of the matter is, I have a wife and kids, and I have a full-time job, so I'm trying to keep the scope pretty finite. And then I think you can see just Glue and Lambda themselves can do some powerful things in regards to data engineering. Okay, let's take a look at this website that I put together for this page. Okay, let's see. Where is it? Okay, here we go. Sorry about that. Okay, this is the web application I put together. These are the steps in my project. I'll get to those in a moment, but let's talk about Baghdad for a minute. Again, I'm from Bagdad, Arizona. I mean, it's a good size copper mine, one of the largest copper reserves in the United States. And then again, a lot of tonnage of, and some ore of like 0.36% copper, and it's in Yavapai County. Arizona has like, I don't know, 15 counties. Yavapai County is one of them. I should probably know the exact number of counties, but I don't remember. But there's good sized counties in Arizona. And then if you want to know more about Baghdad, Arizona, you can see the Wikipedia page. This is the pit. It's an open pit mine. And of course, the company is Freeport McMoran. It was a different company when I lived in Baghdad when I grew up, but that's who owns the mine now. Okay, let's jump back. And so I'm focusing on 3 plants within the mine itself. The mill electrical plant where my uncle worked. And then you have the maintenance and repair shop and the SXEW plant. And you need commodities to really support each one of these plants. You need equipment to be brought in. You need parts and chemicals, especially for the SXEW plant. If you're not familiar with this electrowinding plant, that's where you refine the copper using solvent extraction and electrowinding. Let me show you this picture here. What you're looking at is the electrowinding part of the mine. I mean, this is essentially a huge battery. If you think of your car battery has 6 cells. Think of each one of these as a cell. And like your car battery, it has lead plates in here. It also has electrolyte and sulfuric acid and like copper liquid. What you do is you stick lead and then thin plates of copper inside these tanks. And then by the end of the week, a thin plate of copper will grow to like 200 pounds. They're extremely heavy. And then you have rows of copper plates in here that grow through the electrowinding process. So you have liquid that's copper, sulfuric acid, and like electrolytes. They electrify this whole thing, and then they purify the copper. It's a fascinating process if you've never seen it. This is not Baghdad, Arizona, right here, but it does seem like it's the U.S. Southwest for sure. Probably Arizona, maybe. So let's say if you wanted to support these plants with commodities like logistics support, I mean, you might have to, with like in terms of the electrical plant, order components and get those shipped in. And so you need a logistics supply chain to make sure these plants run effectively. And then you have the repair shop. So just getting parts and components in to make sure the mine operates successfully. Now, if you want to see what these actually look like at Baghdad, you can look at Google Earth. Here's the United States. I think most people are familiar with the shape of the United States, but Baghdad is kind of in between Las Vegas and then like Phoenix. Like almost halfway. This is Phoenix, this is Las Vegas. So it's kind of in the middle there. But in terms of the mine, this is the town of Baghdad. Not a very big town at all. It kind of stretches up in here. And then this is the airport, which is neither here or there, but that's the open pit. And then if you're talking about the mill electric shop, it's been a while since I've been there, but I think it's right around in here where my uncle worked at the electrical shop. And so that's kind of like a 3D perspective of the mine right there. Then if you go to the electro winding plant, now a lot of chemicals, I think this was actually, I don't know if it was sulfuric acid or cyanide, but this tank was one of those two when I worked there. I worked at this part of the plant, and this copper color, the fumes from those cells kind of travel, and it kind of tinges the top of the shed. And then finally, you have the maintenance and repair shed. You have big doors to get heavy equipment in and out. And so each of these components require a certain amount of logistics to make sure that they function like they should. And there you go. The Baghdad Copper Mine. Now, for this project, I wanted to focus on logistics. So I created a team of truck drivers that would supply parts and services or commodities to the mine. I asked Copilot to create a list of 10 fictional drivers, and this is the list that they gave me. They gave me Chris Christopherson from the movie Convoy, Kurt Russell from Big Trouble in Little China, and then Snowman from Smokey and the Bandit. They even gave me Optimus Prime and Peterbilt, and Jason Statham from The Transporter. I don't think he actually drove a truck in that movie, but why not? And then you have Bandit from Smokey and the Bandit. And so by setting up a data engineering project, you can monitor these truck drivers, say if you're interested in Rubber Duck, and hypothetical, say if he was making the delivery from Phoenix, starting off at 5:30 in the a.m. By producing data, you could track his location all the way to Baghdad at 11:06 a.m. and then you can zoom in and have the logistics data to, he's heading to the electrical shop at this date, at this time. And so that's something that you can do with a data pipeline. So let's get to the actual data analysis part. These are the 4 steps that I did in my project. First is data creation. Since the data is fake, I had to generate it myself. I didn't have like GPS locations on the truck. So I created a Python script and an Anaconda Jupyter notebook. I had a collection of points, and then by adding things like, this is the table I produced with dollar values of the commodity being brought in, the type of commodity, whether it was a part, equipment, or a chemical, and then the destination. Again, with the electro winding plant, you're probably getting chemicals. Electrical shop, you're getting parts. Some of this is random, but then some of it is based on the weight of the commodity. Based on the weight, I decided whether that was a chemical or an electrical shop component. So this data is randomly created. So I did a couple years worth of data. This a lot of 2025 records, but anyway, I wrote the script to automatically produce data kind of randomly, and then these are the truck drivers' IDs for each one of the truck drivers. And so if you wanted to see what it looked like in the Anaconda notebook, that would be this right here. This is the actual script, and then it's on my GitLab page, but so it somewhat randomly created data for each of these truck drivers: Optimus Prime, Peterbilt Pete, Cletus Snow from Smokey and the Bandit, then Jack Burton from Big Trouble in Little China, and then their corresponding trucker IDs. After producing the data, I went through the Glue ELT processing and the Lambda scripts. This is an overview of the project that I did, creating the data, then uploading it to a Glue bucket using a Python script in Boto 3, then creating a Glue crawler to go through the data and to put the schema in a bucket or put the data in a like a Glue table, and then through there you're able to query it with SQL through Athena, and then over here you can filter the data uploaded and then put it in two types of buckets using a Glue job. You can filter the data and send some of it to the repair shed, the plant, the shop. You send specific data to each one of those components of the mine. And then you also shift the data based on the driver's ID, so you know which driver produced what, and it's there to be queried. And then using Lambda scripts, processing this data and putting it into a bucket that acts as a website. And so let me show you some of that. Okay, this is the crawler which produced this schema of the data. After submitting the data and the CSV file, the crawler kind of defined the schema. The X and Y coordinates are doubles, and then the F type if a string, the commodity type or the feature type is a string. The dollar value of the commodity is in integers, then the weight is a double, and then finally the destination, whether it went to the electro winding plant or the electrical shop, it's a string as to be expected. And then I created a Glue run job which filters out the data, and I'll show you what this actually looks like. Okay, let's see. Okay, so here we go. This is the Glue job that I created. And so you had the data dump into a bucket from the Anaconda Jupyter notebook. And so I think it was right here, this the plant data. Oh wait, had myself wrong bucket. So the raw data got submitted right here. And let's open that up so you see what it looks like. So this is the amount of data that I produced. And again, where it's heading to the electrical shop or the repair shed, whether it was a chemical equipment or part, the truck driver name, and then the truck ID, and then you do have the timestamp as well. So that got dumped into a bucket, and then using the Glue job, we're filtering that out. And so, like, this is going to the truck driver 104 kind of folder in the truck driving bucket, which is bucket, and then this go to the truck driver bucket, Bagdad drivers. Okay. And so the different truck drivers, this 10 truck drivers with 10 different truck driving IDs. And then you have data when the glue job runs, it will stick the data in here. And then using the Lambda scripts, you can process it, and this actually turns it into CSV file so it can be accessed over the web. So there's like 4 functions, one for the plant data, and then one creating the waypoints for the truck drivers. So, and all of that went into our web page bucket. This is our web app bucket, and so it has the CSV final CSV files, including the ones for the plants, the electrical shop data. If you open that one, it says all electrical shop data that was filtered by the Lambda job. And since you process that, now you can go back in and select your driver, and it'll show you those points. So for Bandit, his actual name in the movie was Boat Thorville, which I never knew that. I just thought he was Bandit. So, and he's heading to the electrical shop, leaving Phoenix at 4:30. And again, when he arrives, it's like closer to 10:06 a.m. So just tracking based on using those glue filters. And so when it gets done with the glue process and then the Lambda scripts to finalize the processing, you can visualize your data. Either through Athena, you can do queries against it, or you can take a look at the data using a data visualizers platform like Power BI from Microsoft. I mean, you could use Tableau, you can use any number of dashboards, but in this example, we're looking at data from the electrical shop, so you can set up a dashboard looking at the drivers, the percentage of, or the sum of the deliveries by truck driver, the sum of the dollar value per type of item that got delivered to the electrical shop, and then monthly statistics. You can also do further analysis in the Jupyter Notebook, and let me show you that. So data analysis. This is our bucket, but it's hosted out as a website, and so you can do a read CSV straight to the electrical shop data. You see the table, and then you can also make bars and graphs and things like that using Python, using Matplotlib, using Seaborn. So making nice graphs out of that. And so, again, let me finish by talking about Athena. Okay, sorry. So this is Athena. You can tie to the glue table created by the crawler. So if you wanted to see all the records, you can write a simple query, run it, and there's your table. Like Rubber Duck Christopherson made these deliveries, but if you wanted to do it by plant, you could do an aggregation or a group by, run that, and you can see the dollar value by part type. So chemicals, this was the dollar value, and then equipment and parts. So you know the dollar amount for each commodity type. Okay. Again, you can use dashboards and visualize the data. And so maybe in the future, maybe I'll try to do some machine learning off of these tables and see if I can't do anything clever like that. But that is the project. The code is in the GitLab link in the description. These web pages should also be in the description. Thank you for